Unlike a conventional wood stove which burns firewood, a pellet stove uses wood pellets as fuel. Made from lumber byproducts such as sawdust and wood chips, which would otherwise end up as waste, pellets burn more efficiently and more cleanly than wood and produce very little air pollution. A pellet stove has an onboard storage container called a hopper, which holds, depending on the model, up to 36 kilograms of wood pellets. Several computer chips monitor the stove's heating performance, dictating the rate at which the hopper automatically feeds pellets into the stove's fire pot. The heat output is manually adjustable or can be controlled by a thermostat. Wood pellets burn far more cleanly than logs, and the fire is smoke-free. Wood pellets are made from a variety of raw materials: sawdust, wood chips, wood shavings, small logs, even scraps of wood left over from furniture and other manufacturing. These different types of lumber byproducts first have to be reduced to the same size and consistency. Therefore, the first stop is a huge grinding machine. Inside, mammoth steel hammers pulverize the raw material to uniform pieces. The raw material contains about 45% moisture, so it goes into a dryer to reduce the moisture level to between 11 and 12%. What was rough raw material has now been ground to a finer state and dried. But it's still not fine enough. So it goes into a mill, which processes it further until it's roughly the size of rice grains. A feed pipe transfers what is now wood fiber to a row of presses. These are the machines which make the pellets. The moisture content of the fiber is critical. If it's too wet, the pellet presses risk clogging up. That's why each pellet press has a readout displaying the fiber moisture level. As an added measure, the factory draws fiber samples and sends them to the quality control lab for analysis. It's essential for the stability of the pellets that the moisture be at the ideal level. Excess moisture would eventually evaporate, breaking the pellets apart. So, to analyze the moisture content, the lab technicians weigh a sample, heat it to a high temperature to evaporate the moisture, then re-weigh. The analyzer is programmed to translate the weight loss into a reading of moisture content. The pellet press is a large drum with perforated rollers inside. The holes are pellet width, a ½ centimeter in diameter. As the drum rotates, the rollers apply pressure. This compresses the fiber by 400% and extrudes it outward through the holes. A knife slices the extruding fiber at programmed intervals, cutting it into lengths of just more than 3 centimeters. The compression generates heat, which draws out the tree sap still contained in the wood fiber. This sap, called lignin, acts as an adhesive, locking in the pellet shape. The journey from raw material to pellet is now complete. The pellets, however, are still quite warm and sticky, so they clump together. The solution? About 15 minutes in a cooler. As the room temperature air blows through the pellets, cooling and drying the tacky lignin, the pellets separate from each other. Some of the processed raw material ends up in too fine a state to become pellets. So, as the pellets exit the cooler, a vibrating screen filters out this sawdust-like material, which incidentally doesn't go to waste. The factory uses it to fuel the dryer. The pellets, meanwhile, proceed to packaging. It's a continuous system. The machine feeds printed plastic film around a cylindrical tube, forming the shape of the bag. Then it drops in 18 kilograms of pellets and seals the top of the bag, simultaneously forming the bottom of the next one. Wood pellet stoves are fast becoming a popular means of home heating. And because pellets cost significantly less than most other types of fuel, Wood pellet systems are an emerging option for commercial and industrial heating.